Hello, dearies. This is Miss Medina, and today we're going to be working on continuing with the notes, classifying and adding, subtracting polynomials. Adding and subtracting are pretty much the same thing. When you're subtracting, you're adding the inverse, but here we go. The standard is APR 1, and it's a very, 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 very important standard that you need to master because you're going to need it in geometry, you're going to need it in algebra 2, and you're going to need it in your last math class. And if you go to any type of certification college classes and they give you math, you might need it there as well. Here we go. Adding and subtracting and multiplying polynomials, dividing, we're going to save that for algebra 2. It's you understand that polynomials form a system that is analogous to the integers. What? They form a system that is very similar to the positives and the negative numbers. Analogous to the integers just means that the polynomials work the same way as the numbers that we were taught in elementary and middle school work. And they're also closed under these operations. That means you take two polynomials, add them, and you still get a polynomial. You take two polynomials, you multiply them, you still get a polynomial. Okay, kind of like if you take two integers, you add them, you still get an integer because they're rational numbers. Rational plus rational, remember, still gives you rational. The definition, a polynomial change the color on this, is an expression that can have constants, that means it doesn't have to, okay? But it can have one of them or all of them, constants, variables, and exponents. Now, polynomials cannot, and I repeat, cannot, I wish I had red to highlight, polynomials cannot contain radicals. Now that is misleading. It should say variables under the radical sign. It cannot contain variables under the radical sign. And yes, I'll give you more examples later on. Fractional exponents, that means exponents that are not whole numbers. Where's my highlighter? Negative exponents, no. Negative exponents in anything in the numerator. In case it's a fraction. And it cannot have variables in the denominator, which you'll learn eventually is the same thing as a negative exponent. So what is a polynomial? It's an expression that's going to have constants, variables, and exponents, but there are some no-nos that you need to master and be able to identify. Let's see. Shall we list 3 examples of polynomials? Well, they're right here. Let me see. 6x or 6x minus 3 or 3x squared or 3x squared minus 3. You see, they're all constants, variables, exponents, nothing fancy. It could be 3x squared plus 5x minus 3. And yes, you can get really crazy really fast. It could be 5x to the 4th plus 4x cubed plus 3x squared minus 2x plus 10. Yes, like I said, polynomials are expressions that can have constants, variables, and exponents. And notice that there's nothing here that says there's a limit. So polynomials are named by their degree, by their exponents, or otherwise known as the degree. and the number of terms. So the degree is going to be the sum of all exponents of that variable or of that term. Okay, so an example, what is going to be the degree? So we have 3 terms here. Let me zoom in because I can barely see it. So the first term is 2x squared. The second term is 5x. And the last term is negative 3. To tell the degree of a term, you have to look at the exponents on the variables. So 2x squared only has one variable, x, and the exponent is 2. So ergo, the degree is 2. Right, looking at 5x. 5x only has a single variable, x. And if you look at the exponent, because we don't write anything, that's an understood 1. Please, so the degree for this one is going to be 1. Right? Understood 1 right there. Negative 3 has no variable, so the degree is going to be 0. So all constants have a degree of 0. All right, let's try this again. 4x. 4x has a single variable, and its exponent is 1. So it has a degree of 1. So next one, negative 3x to the 5th. Once again, only one variable, and the degree is going to be 5. Say it with me. Repeat it so you get comfortable, so you don't get tongue-tied afterwards. Plus 2x squared. Well, you look single variable x, and the exponent is 2, so the degree is 2. And lastly, should I pick orange? Orange sounds good. Negative 1. Negative 1 has no variable. And when you don't have a variable, your degree is 0. All constants are 0 degree. All right, so let's see. Let's continue this. All right, it says to non-examples, cross off all the expressions that are not polynomials. All right, so over here, highlighted in green, we have all the stuff that cannot be polynomials. So let's look at this first example right here. Okay, 1, I apologize, 1 over x to the 3rd. Which rule are we breaking? The last rule, the one that says variables. Now let's put numbers on these. Number 1, number 2, number 3, and number 4. Which rule are we breaking? We're breaking rule number 4 because it says that we cannot have variables in the denominator. And this one has an x in the denominator, so this is not a polynomial. All right. Now let's look at the next example. 3x to the 4th. And then minus radical x, or minus the square root of x. It looks like we're not breaking any rules on the first term, but we're breaking a rule on this second term because rule number 1 says that we cannot have variables under the radical sign. So is this a polynomial? No. The whole thing gets disqualified if one term doesn't meet the standard. All right, let's look at the next one. 4x squared. That looks pretty good. There's no radicals. There's no fractional exponents. 2 is pretty whole. Negative exponents, variables. Oh, we're pretty good. Green light. This one is an example of a polynomial. All right, let's look over here. Negative 9 plus x. So this one has 2 terms, the negative 9 and the x. Negative 9 is a constant, so that's pretty good. X raised to the 1st power. Once again, we're not breaking any rules, so this one as well is an example of a polynomial. Okay, let's look at the next one. Negative 8x to the 5th power plus 2x minus 7. So this one has 3 terms. So let's check the first one. Negative 8x to the 5th. Seems pretty good. There's no radicals, there's no fractional exponents. 5 is pretty whole, nothing, no exponents are negative. We're good. 2x, once again, we're good. We're not breaking any rules. -7s, all constants are good. So this one as well is going to get our green light. You may now enter. And let's look at this last one. 6x raised to the -2. -2. You see how we're breaking rule number 3? Negative exponents in the numerator. So this one does not meet the standard. -3x does, but once again, as long as one of them doesn't, the whole thing does not meet standard. Okay. All right, so you might want to rewatch this to make sure that you fully understood. And we'll end the video right here, and I'll continue with the notes, okay?